So first off, good afternoon, everyone. Thank you for being here. It is so exciting to be in front of a crowd that is as excited about passwords as I am. I very rarely get that opportunity at work. My name is Ricky Mondello. I'm a software engineer at Apple over in California. And today I'm here to tell you all about some things that iOS does to encourage healthy password practices. So first off, let's get started with just a little bit about me. At Apple, I've worked on the Safari team, the Safari web browser, the iCloud Keychain password manager, and the password autofill feature that ties those two products together. This last year, I was super lucky. I was lucky enough to work with a group of talented, passionate people on several different projects to make password management better on iOS. And so today, I'm going to be presenting a bunch of their work and their ideas and some of the things that we all learned together. So, how iOS encourages healthy password practices. My agenda is going to start off by what our goal was, what we wanted to achieve with iOS 12. Then, I'll give some background about Apple's password manager, iCloud Keychain, as well as the password autofill feature that many of you might be familiar with. Then, I'll cover what we achieved, some of the things that we did in iOS 12 to make authentication better. And then, I'll turn to developers. Any web developers, app developers, operating system, browser developers, password manager developers who might be listening right now, and talk about a few areas where people can help with encouraging good password practices. So let me get started by talking about the problem that we wanted to solve. And this problem is going to be familiar to all of you after the last 2 days. The problem was that people reuse passwords. And this hurts people because it increases the odds that they're going to be compromised, that they'll get hacked on a service. And when a user reuses a password, they open themselves up to compromise of their identities, their reputations, their finances, and in some cases, even their physical safety. This is really important stuff. And if you run a service, if you happen to run a service that has a password that's used for authentication, the password reuse problem ends up being your problem. Because when a user's account is compromised on your service due to password reuse, it's a hassle for you. The user might think that your service was compromised, and at the very least, they're going to be coming to you for support. So how do we deal with password reuse? What can we do here? Well, there are a few different ideas. Some people will tell you that we need to remove the use of passwords entirely in order to solve this problem. And I wholeheartedly support work that moves us closer to a world where this is possible. But that's not what this talk is about. We also know that two-factor authentication is amazing for reducing the value of a password. If a password itself isn't sufficient to gain access to an account, which is especially important when a password is reused. But that's also not what I'm going to be talking about today. What I'm here to talk about is how to encourage healthy password practices. How to make it easy for users to do a great thing instead of doing the wrong thing. And in fact, that was our biggest goal. Did it cut? OK. So in fact, does that sound good? Hello, hello? OK. So in fact, encouraging healthy password practices was one of our main goals with iOS 12. As long as we have passwords, there has to be a healthy way to use them, and a way that doesn't involve keeping one or just a few of them in your head. So how do we do it? What does healthy mean? To us, we define a healthy password practice as having strong, unique passwords for every online account. So throughout this conference, we've been talking about walking up to local workstations and online accounts, and we've kind of been shifting between those two topics. Right now, I'm talking about the dozens of online accounts that each of us have. So why isn't it the case that people are already using strong, unique passwords for all their accounts? Frankly, my colleagues and I think that the reason is that it's easier and more reliable to not do so, to use the same password everywhere. That convenience and reliability are the keys to password management adoption. This is a human problem that we know that computers can solve for us, and so that's what I'm going to be talking about today. And this idea of what we want to do also comes with a strategy that I'm really passionate about, which is the idea that we can do a lot of good very quickly for a lot of people by working with existing infrastructure, by working with the thousands and thousands of login forms that users are used to seeing all across the web and in apps. I think that we can abstract over these forms. We can abstract over them and transition users away from thinking about passwords as something that they created, something that they have a personal relationship with, to something that's completely opaque to them and handled by a password manager. And if we get far enough along this, maybe we'll even get to a point where those fields become invisible, and there's just an affordance for signing in and consenting to sign in. With this hypothetical future that I'm talking about, the mechanics of authentication would be exactly the same, just without the part that humans are unfit to do, which is be a source of randomness and have perfect memories. We already know that that's not going to work. And because this landscape is so large, I mentioned thousands and thousands of sign-in forms, there are so many actors, and all of us have a role to play in building toward this future, where by default, users are doing the right thing and have strong passwords across all their accounts. So this is a collective problem. It requires a collective solution. And I'm really happy to be at this conference because I think that that's part of a collective solution. So now what I'm going to do is I'm going to transition to the role that Apple is trying to play in this space as an entity that owns several platforms that users use. So just to make sure that we're on the same page, I want to cover some background about iCloud Keychain. Every iPhone, iPad, and Mac ships with a built-in password manager. It's called iCloud Keychain, and it is integrated very deeply within macOS and iOS. Users are very strongly encouraged to use it. It's the default. They're prompted to turn it on while they're setting up their devices. And it securely synchronizes passwords across all of a user's devices without ever storing a password, obviously, in plain text on a server, and never encrypted in a way that Apple can read. Apple never has the keys. It's a device-to-device mechanism. At the end of the talk, I'll actually link you to a document, a white paper that Apple has, where you can learn more about how this secure authentication mechanism works. So like any password manager that you're probably familiar with, iCloud Keychain has an interface for looking up and managing passwords. On iOS, this list is integrated directly into the user's settings, where they can find it. But that said, a list like this isn't how most of our users experience iCloud Keychain. Most of the time, our users experience iCloud Keychain through the password autofill feature that's integrated into their web browser, which on iOS is typically Safari. And it's true, on Apple platforms, password autofill did start off as a web browser feature. And prior to the spring of 2018, the way that most users would encounter iCloud Keychain and password autofill would be by visiting a web page that looks like this, and the browser, very quickly after the page loaded, automatically populating the web page with their credentials so that it was just a single tap to sign in. Many of us have probably seen this before in web browser password managers, but we actually removed this feature last spring when we shipped iOS 11.3. And the reason that we removed it is because we were alerted to the fact that something was happening on the web, that the web had changed. Some privacy researchers at Princeton University let us know that real-world websites, and many of them, were embedding third-party advertising JavaScript that was injecting hidden or almost hidden forms into web pages, waiting for web browser password managers to pre-fill them with the user's credentials, and then they were scraping the usernames out of them. Now, usernames are frequently email addresses. So with an email address, what these third-party JavaScripts got was a unique, cross-device, stable tracking identifier. And at Apple, we believe that everyone has a fundamental right to privacy. So what were we going to do? After thinking through all of our options, we actually decided to remove this feature from Safari, remove the ability to pre-fill user credentials to make it really easy to sign in. And I have to tell you that having to remove a decade-old browser feature due to abuse on the web is not my favorite experience. It's actually a real shame. But this story actually has a silver lining. There were some upsides to doing this. So the first is that we were able to take a look at our interface and see if we can make it even better. So in iOS 12, we introduced a new feature that restores some of the convenience of like one tap to sign in. So when you load a page that looks like this, a page that looks to our heuristics like a sign-in page, will automatically throw up a new keyboard on iOS. And this keyboard isn't a normal keyboard. It doesn't have a row of a bunch of letters like ASDF. Instead, what it does is it draws your attention to one single blue button to sign in to the app using, to the website using iCloud Keychain. And this big blue button, besides being really convenient, enforces our worldview, which is that passwords are a thing that are meant to be handled by your password manager, put in the places that they're needed, and not something that you need to create, remember, or even type. And so with just one tap of that big blue button and a quick Face ID or Touch ID check, boom, the information is in the web page, and you can log in with just one more tap. We always wanted to go just a little bit further with the great biometrics that we have on iOS, Face ID and Touch ID. We wanted to use them to guarantee that credentials would never be released to an app or a website without the presence of the user through these biometrics. Now, this was really challenging for us when we had a pre-existing feature that automatically filled passwords onto web pages without users doing anything. But now that we had to remove that feature in the name of user privacy, we actually had an opportunity, and so we did it. So now in iOS 12, by default, Face ID and Touch ID are required when disclosing credentials to web pages or to apps, and that was already the case when you looked them up. So now by default, there's a hard rule. Anytime that you're accessing a password or disclosing it to anyone on an iOS device, biometrics are going to be required. And this is really cool because this eliminates any concerns about walk-up attacks that people have had in the past about browser-based password managers. So now, thanks to the biometrics, by default, it's not possible to walk up to a friend's unlocked device, visit a web page, have it fill credentials for the user, and then trick the web page into disclosing those credentials to you somehow. These walk-up attacks are now a thing of the past. So that's just a little bit about how Safari and autofill have evolved recently. And Safari and autofill, password autofill, go together very nicely. Password autofill started off as a web browser feature. But in the last few years, we've actually, on iOS, turned it into something much more than that. As of iOS 11, autofill is now built into almost every single iOS app that has a username and password field in it. And this is really great. Because with that button, you can tap it right on the keyboard and pull up the list of all the saved passwords that you have on a device. And then you could fill them without having to copy and paste them or without ever having to leave the application. And this is really important because it greatly reduces the friction of using passwords that you don't know. You don't have to switch apps, you don't have to copy paste. The hassle is greatly reduced. So this is system-wide. And in some apps that declare a secure association with a website that iOS is able to validate, will actually suggest the exact correct credential for the website affiliated with that app on the keyboard, so that it's just really one or two taps to get signed into an app. And this feature is huge. Again, the point here is to reduce the friction of doing the right thing, which is using strong, unique passwords, making it easier to do that thing than to use memorable, weak passwords all over the place. And this is another important point. Just like the autofill feature in a web browser, password autofill for apps requires iOS app developers to do very little to get the feature. They don't have to be experts in authentication. They just have to have a password field, and then it'll be available by default, which means it's in tons of apps. So again, just to summarize this background information, iCloud Keychain is Apple's password manager. It is used by hundreds of millions of people across the planet, and it is integrated deeply into iOS and macOS. This is a responsibility that we take very seriously, having this password manager. And with that, let me get along to telling you about some of the things that we did to encourage the use of strong, unique passwords across websites that users encounter and apps. We did a lot this year, but I'm just going to cover 5 things for right now. And the first is the most important thing, which is guiding users to using strong, unique passwords at the very moment that they'll be tempted to not do that thing. So we did this with a new feature that we call automatic strong passwords. And the big idea with automatic strong passwords is that there's now a password generator built into iOS apps. So here's how it works. This is an iOS app, a demo iOS app. And when the user is on a screen like this, the temptation to check out their shopping cart or create that account really quickly, it's going to be high the temptation to type out a memorable password is going to be extremely high. And so what iOS does is, at the moment that the user taps in the password field, iCloud Keychain steps in and inserts a strong password for the user. And it does this with education, with some text there, that educates the user about where they can find that password if they need it, not on this device. Now, of course, on all of their Apple devices that have their iCloud keychain, the passwords are synchronized, they'll be autofilled, big blue buttons, you get it. And this is a very strong suggestion. It is not a hard requirement, it is not a trick, it is a proactive, relevant suggestion for the user at the moment where they're most tempted to do the thing that we know can hurt them and put them in danger. So with a single tap of that big blue button, using a strong password might actually be easier than typing out your memorable password, which is pretty great. Automatic strong passwords is present in apps, and that new UI treatment actually replaces the password generator that's in Safari. Safari's had a password generator for years, but it was an opt-in feature that users had to invoke themselves. Now, automatic strong passwords makes it the default that you'll do the right thing. So next, this might surprise you. Next, I want to talk about why and how we changed the format of passwords that we generate for users with iOS 12. So to do that, I first want to look at our previous password format. So it looks like a pretty scrambled password. It's just 4 chunks of alphanumeric characters separated by 3 hyphens. And when we were designing these passwords years ago, our strength goal was to make an offline attack against a salted database that was using a relatively weak hashing function, somewhat expensive. And if you want to speak in terms of Shannon entropy, this password format had just under 70 bits of entropy. And we used this format for many years. Here are a few more of these passwords. And one day, internally at Apple last year, we had an internal demo of the new automatic strong passwords feature. Great demo. And my colleague Maciej came up to me after we had given that demo, the team gave that demo, and told me that he had one time where he regretted using computer-generated passwords, which was when he was trying to sign in to an account on his game console, where it didn't have his keychain on it, there was no password manager integration there, and the keyboard to type on the game console wasn't actually a keyboard, it was a game controller, and that was particularly hard to do. And he explained that the passwords were particularly hard to type because he had to switch which keyboard mode he was in many times while typing the password. And at first, I listened to him, I believed him, but I wasn't sure about how important this was at first. And then a few days later, he came back to me with a prototype implementation of a different password generation format. And at that point, he had completely convinced me that we had a problem here that we needed to solve. And not just because he had already implemented some of it for us. The reason he convinced me was because it was so clear that he felt so strong about this, that this was a moment that despite the fact that the password was going to be more secure because it was computer generated, he was going to try to abandon it anyway to go back to using a weak, memorable one. Here is a new password generated by iOS 12. To make these passwords easier to type on suboptimal keyboard layouts like my colleague's game controller, where the mode switching might be difficult, these new passwords are actually dominated by lowercase characters. And to make it easier to short-term have in your head little chunks of it to bring over to the other device, the passwords are based on syllables. That's consonant, vowel, consonant patterns. With these considerations put together, in our experience, these passwords are actually a lot easier to type on a foreign, weird keyboard, in the rare instances where that might be needed for some of our users. And we weren't going to make any changes to our password format unless we can guarantee that it was as strong or stronger than our old format. So if you want to talk in terms of Shannon entropy, once again, these new passwords have 71 bits of entropy, up from the 69 from the previous format. And a little tidbit for folks who are trying to match our math, we actually have a dictionary of offensive terms on device that we filter these generated passwords against, and we'll skip over passwords that we generate that contain those offensive substrings. We use the generate and validate approach that Rob talked about yesterday. So these new passwords are 20 characters long. They contain the standard stuff, an uppercase character. They're dominated by lowercase. We chose a symbol to use, which is a hyphen. We put 2 of them in there, and a single number. We picked this length and the mix of characters to be compatible with a good mix of existing websites. And a few more details. These aren't real syllables as defined by any language. We have a certain number of characters we consider to be consonants, which is 19. Another set we consider to be vowels, which is 6. And we pick them at random. There are 5 positions for where the digit can go, which is on either side of the hyphen or at the end of the password. And one more tidbit is that our first attempt at generating these more typable, short-term, memorable passwords actually led us to generate passwords that were 21 characters in length. We had the syllables, and we tacked the number onto the very end. We quickly learned that there is a drop-off point where websites, a lot of websites, will accept a 20-character password and reject a 21-character password. So we found a way to keep all the strength and go to a 20-character password. We paired having more typable passwords with having an easier way to look up passwords. So now on iOS 12, to log into that game console, you can just ask Siri, what's my Netflix password? And after authenticating with biometrics with Face ID or Touch ID, you'll be taken directly to the password so you can go ahead and type it on the other device. This was just a nice thing that we did to make living in a world where you don't know your passwords a world that you actually want to live in. So next up, now that our users are using strong passwords by default across all of the new services that they're signing up for, how do we help a motivated user get to a good state where they're not reusing passwords? Now in iOS 12, in the list of saved passwords that I showed you earlier, we put an indication as to which passwords that you're reusing across multiple services with a little warning badge to incentivize you to go and change them. When you drill into one of these passwords, you'll see a hyperlink that'll take you to the website that the password is saved for so that you can use automatic strong passwords to update the password and get into a good state. And in a moment, I'm going to tell all of you about a way that your websites can integrate with that hyperlink to offer users the absolute best experience. And now, we had this little performance earlier, but I'm going to talk about that performance. I'm going to take a step back from iCloud Keychain and tell you all about the third-party password manager integration that's present in iOS 12. So for users who prefer to use a different password manager, they can go ahead and visit Settings and turn on their password manager of choice to use as a data provider for password autofill. And after they've done that, this means that in both Safari and in all of the user's apps, they'll get the same convenient password autofill filling experience that they would have gotten with iCloud Keychain. And as you all just saw, some of our users and friends, developers, absolutely love this feature. And I love this feature too, not just because it encourages good password practices and healthy password use, which, as I told you earlier, I think is actually good for all of humanity, but because it actually helps us all work together for the same goals. So now, website and app developers only have to care about and test with a single system, password autofill, in order to have compatibility with password managers for the most part, rather than having to adopt dozens of different native APIs and web integrations. And now that that's the case, we can work together to evangelize healthy password practices, which I think is huge. I mentioned earlier at the beginning of my talk that I think that everyone has a role to play in this space, and offering this integration is kind of part of what I mean. It's awesome when we can work together to get out the message that passwords are something that a computer program should handle for you, and not something that, for the most part, you should create by hand and keep in your heads. And so now, in that same spirit of collaboration, depending on who you are, I have a few tips that you might be able to apply or might be able to pay forward to other people who you know who develop systems that use passwords. So these will be tips for web, app, OS, browser, and other password manager developers. And the first recommendation is for app and website developers, and it's pretty foundational to everything else. And it is to consider password autofill when designing your apps, your websites, and your backends. In the past, some users explicitly chose to use a password manager to generate a computer-generated strong password. And now, with iOS 12, this is a choice that an operating system like iOS is making by default for users, for hundreds of millions of people. All iOS users have a password manager that's enabled by default. The landscape has kind of changed a bit here. And iOS isn't alone in doing this. Other browser manufacturers are also now shipping auto-generated password features, which is great. And if you're part of an organization that at some point in the past decided to thwart autofill for some reason, to make it difficult for users to use a password manager, I'd really like you to reconsider that. As we speak, iOS users across the world are getting used to the fact that computers will generate passwords for them and fill them and do everything for them. And as I mentioned earlier, iOS by default now protects users from walk-up attacks because we're strictly enforcing the use of those biometrics on our devices, Touch ID and Face ID. So now is a great time to reconsider password autofill if you'd made a decision about it in the past. If you're part of an organization that has password-based authentication and you have a website, I just have a few flows that you should think about testing when thinking about working with password managers. And if you test these 4 things, you'll be in pretty good shape and know that your users will be in good shape too. So the first is to log into your website without having any saved credentials in iCloud Keychain and check that iCloud Keychain offers to save them. At that point, go ahead and say yes. Then log out. Go back to the sign-in page and check that autofill is offered and that when the user invokes it, that signing in succeeds. That's the second step. After that, sign out again, and if your website supports it, go ahead and create a new account. Use automatic strong passwords or other password managers' password generators to generate passwords for your website, and check that the passwords were compatible and that the user was able to finish registration. And then finally, we'll kind of combine some of the above steps. Go ahead, sign out, sign back in, and go to change the password. This kind of just combines the new account step and the sign-in step. Update the password and check that it's compatible with the passwords that automatic strong passwords generates. And that's basically it. And if something doesn't work right, I have a few quick tips for web developers right now. The first thing to know is that password autofill features in browsers are typically built with heuristics. So helping out password autofill to do the right thing typically is in the form of informing the heuristics of what your website is trying to do, what the meaning of your website is. So my first tip is that you can actually use the old autocomplete attribute with 3 new values to tag your username fields and to make it clear to a password manager whether a password field is for a current password in a login scenario or a new password in a sign up or change password scenario. And so this is just a really easy way you can tell the password manager what your fields are, what they're for. And a cool tip, you could actually put in Safari, a hidden username field, so a hidden text field not visible that's tagged with autocomplete equals username to specify which account the user is changing their password for at the moment. It's a really cool way of resolving the ambiguity of a user just visiting a change password page and the password manager not knowing which account is being updated. If you have one of those, I mean, they're not new or fancy at this point, but in the age of the web, new and fancy websites that don't do full page loads in between every single page, you can use the history push state and replace state methods to signal a generic state transition. And this is really useful for password autofill in Safari, because when you do this, this will be a moment that we can commit any unsaved new generated passwords to our database as an indication that the user actually succeeded in the operation that they were doing. It's important to read data directly from text fields rather than have fancy systems for tracking the user as they're typing, because password managers might trip those systems up. So text input fields have a value attribute. You could read right from it. It's great. It's a property. And finally, this might not apply to any of you, but you can use the min length, max length, and this new attribute called password rules to help password managers generate compatible passwords for your service. So we actually designed an entire language that, again, I hope that none of you have to use to make sure that when iOS gets to your website or your app and tries to generate a password, that it generates a password that's compatible with your service. And the reason that this is important is because that when a user is using any password manager and they generate a password and a website rejects it, that is a huge moment of cognitive dissonance. Their password manager is saying, hey, I'd made a strong password for you. And the website is going, nah. And like that doesn't play out well for users. They get very confused. So we want to avoid that whenever possible. And we actually made an entire web-based tool that you can use to play with the new language that we created. And I'm going to give you a quick tour of it. So at the top, you can learn about what password rules are. There's a hyperlink that'll take you out to our documentation for password rules. In the middle, you can edit and validate the rules that you want to use with your service, with your website or your app. And here, you'll see that we pre-populated a set of rules that's equivalent to the rules that iCloud Keychain uses. Requires an upper, lower, digit, and a hyphen 20 characters long. Upper, lower, and digit are just special named sets in the language. And you can see that with the square bracket syntax and the hyphen, that you can define your own character sets. So you can list out all of the special characters that your website expects or can use. With those character classes, you can have more than one character in them. Here, I'm specifying that a password must either have a hash or a plus sign in it. And by doing this instead, I can say that a password must have a hash and must have a plus. So it must have both of them by having two different lines that specify that. I also changed that upper and lower are now allowed, that they're not strictly required, but they're allowed. And the more things that are allowed and not required obviously makes the password stronger. So after you've written and validated your rules, you can scroll down on the page, and you'll see that you can copy out rules that are appropriate for UIKit-based apps on iOS and rules for Safari in a web browser. And this is the most important part of this web page, is at the bottom, as you're typing your rules and crafting them, the 3 generated passwords on the left will live update with passwords that are compatible. And on the right, you can download 10,000 of them that are generated with those rules and run them against your validation logic to make sure that the passwords are completely compatible. So again, we tried to make iCloud Keychain's password generation logic as compatible as possible while meeting some of our other goals. And in the case that it's not compatible with your existing system, you can use the password rules language and tool to bridge the gap between password managers and your service. And of course, I can't emphasize this enough. Any constraints that you put on what a password manager can generate will weaken the strength of passwords that can happen. But obviously, we need to put first and foremost compatibility with your existing services so that users get a good user experience. Here is the URL for that website, the password rules validation tool. And we've shipped this language as part of iOS 12 for native apps and Safari 12 on macOS and iOS. We're using this in the wild today. And if you think that your password manager could benefit from adopting rules like this, or you have any feedback, or you'd otherwise like to see this standardized, please come and talk to me after the talk. I would love to talk to you about that. Earlier, I told you about password reuse auditing, the feature where users can, if they're motivated, go and clean up what reused passwords that they have. When they drill in, they're given a link to go and change their password. And earlier, I told you that this link did something really cool. So when the user taps on this link, we're going to construct a special URL to visit on the web page. In this case, it's example.com. And the link looks like this. It reads https://example.com/.wellknown/change password. And the important part is the path. And this part of the URL, the .wellknown part, is actually part of an existing standard. So this is just a location on servers that web developers can put standardized resources that web browsers and other automated tools can access at known paths. So for instance, website icons typically sometimes go in the well-known directory. This part, change password, is the part that's new, and the part that we've now actually, Apple has proposed as a standard, a new web standard. And when Safari loads this URL, when the user taps on it, the server can do anything that it wants with it. Now, obviously, what we want the server to do is if the user is logged in, take the user directly to the form where they can update their password. And if the user is not logged in, take them to a login form, and immediately after take them to the form where they can update their password. So that when they're updating 30 reused passwords in a row, that process can go much more smoothly for them. If a website doesn't implement this, which it would tell us by returning a 400 or 500-ish error, That's totally fine. What Safari does is just redirect the user back to the root of the domain so that the user can go and log in themselves and update the password. This proposed standard is being worked on by the W3C's Web Platform Incubator Community Group. It is one of the most simple specifications that I've ever read. It takes less than a minute to look at. I encourage you to go check it out. And if you work on a password manager, you can use this well-known URL similarly to how iCloud Keychain is using it today. There is nothing stopping you from doing this. It would be great, actually. And those are some of the ways that developers can help out with Apple's mission as a platform provider of encouraging healthy password practices, where users have strong, unique passwords across all their accounts. So to summarize, I think that passwords are worth improving. We do not have to transcend them to help people. Making passwords better doesn't harm any efforts to replace their use, and it doesn't harm adoption of second-factor authentication. We can work on all of these things at the same time and help out a lot of people. Anything that we can do to improve the convenience and reliability of password managers will make the world a better place. We at Apple felt so strongly about this point that we've built a password manager into our operating systems. We have been and will continue to put time into iCloud Keychain. We think it's an awesome password manager. And if you have a system that requires a password for logging in, you can help. With just a little bit of time, you can take a new fresh look at your website or app and see if it's compatible with password managers like iCloud Keychain. And then you can go ahead and adopt the well-known URL for changing passwords to ensure that users get a really fluid experience when they go to upgrade their security on your website. Here are some resources that I was kind of promising as I went along in the talk. The iOS Security Guide is a fantastic, approachable white paper that describes lots of aspects about how iOS's security model works. It's actually a pretty approachable read. It was updated this last September. And with that new update, it actually has an entire new section about user password management, which is brand new. It goes into even more detail about iCloud Keychain than I had time to go into today. Automatic strong passwords, the second item, refers to a WWDC session that some of my colleagues gave at Apple's developer conference this last summer. Today, I focused on tips for integrating with password managers for websites. That session goes into detail about how to integrate those with iOS apps. There's the password rules validation tool. And while you're on github.com checking out the specification for the well-known URL for changing passwords, if you have a moment, you should do something cool, which is edit that URL to put in the well-known URL for changing passwords. GitHub.com has already adopted it, and I'm really happy to say that their implementation is perfect. And finally, if you have any questions or want to get in touch, I'm Mondello on Twitter. And Jonathan Davis is the name of the Safari and WebKit evangelist. He's a pretty good follow, too. Thank you so much, everyone.